Quantum computers and AI are an explosive combination. Some expect AI to change the world more than fire or electricity. It's already enhancing everything from self-driving cars to deep space exploration. And it holds the promise of dramatically extending our lives, or, of course, replacing us. Quantum computers won't just accelerate AI, they will break open doors that classical computers never could. To see why, we need to understand the special connection between AI and quantum computers. AI learns from experience, calculating the likely outcomes of many possible choices.
After training in millions of rounds of hide-and-seek, the hiders find a solution. The hiders learn to use rudimentary tools to their advantage. After many millions of rounds of having their shelter breached, the hiders learn to take away the primary tool the seekers have at their disposal. To prevent seekers from using the ramps, the hiders move them to the edge of the play area and lock them in place. The seekers discover that they can jump on top of boxes and surf them to the hiders' shelter.
AlphaZero taught itself chess by playing against itself. In just 4 hours, it learned enough to beat the previous champion, which had a lot of human input.
I'm very close to the cutting edge in AI, and it scares the hell out of me. It's capable of vastly more than almost anyone knows, and the rate of improvement is exponential. You can see this in things like AlphaGo, which went from, in the span of maybe 6 to 9 months, it went from being unable to beat even a reasonably good Go player to then beating the European World Champion, who was ranked 600, then beating Lee Sedol 4-5, who had been World Champion for many years, then beating the current World Champion, then beating everyone while playing simultaneously. Then there was AlphaZero, which crushed AlphaGo 100-0. And AlphaZero just learned by playing itself, and it can play basically any game that you put the rules in for. Whatever rules you give it, literally read the rules, play the game, and be superhuman.
To find a life-saving drug, the choices must be far more precise, and the options are almost infinite. Supercomputers could take thousands of years. But quantum computers play a different game. This one looks like a death ray because it uses several cooling stages to reach temperatures colder than outer space. The colder, the better, because when atoms are kept still, their quantum effects become more clear. This is an oxygen molecule, 2 oxygen atoms sharing an electron. The electron doesn't sit between the atoms, it exists around both of them at the same time. This is called superposition, and it holds molecules together. Without it, your body would fall apart. The particles at the center of quantum computers can also be in 2 positions at once. While classical computers use bits, 1s and 0s, qubits can be 1 and 0 at the same time. Observing a qubit makes it collapse into a position. No one knows why this happens. If you can figure it out, there's a Nobel Prize for you. Flip a coin enough times, and the probability of heads and tails will become clear. In the same way, repeatedly measuring a qubit will uncover the probability that it's in a particular position. Nature is also quantum. Our brains and the drugs we're searching for work in probabilities, so they can only be accurately simulated on quantum computers. Another spooky skill of particles is entanglement. 2 separate particles can be connected so that changing one of them will immediately change the other. There's no physical connection. They can be at opposite ends of the galaxy. If we entangle 2 qubits, they can be in a superposition of 4 basic states: 1, 1, 0, 0, 1, 0, and 0, 1. Each time we add a new qubit, we double the total number of states. To double the power of today's fastest supercomputer, we would need to double its size. But for a quantum computer, it's just another small qubit. With 300 entangled qubits, the number of possible positions is greater than the number of atoms in the known universe. That's how many bits a classical computer would need to compete. Quantum computers will accelerate drug discovery by accurately modeling chemical reactions, which is impossible with classical computers.
Many of the ailments we call diseases could be thought of as symptoms of the most powerful disease of all, aging.
In fact, for some species, death rates actually go down with age. So instead of getting sicker and sicker as you get older, you get healthier and healthier. They tend to be species that keep on growing, and as they grow, they get to be bigger and get new tissues, so they restore their health.
There are whales that live hundreds of years, and they're very similar to us genetically, but we do need to be able to either change our genomes or find medicines and other ways to enhance our systems so that we have the same kind of lifespans that they do.
Quantum algorithms will also detect patterns in our behavior and perhaps come to know us better than we know ourselves. This will undermine democracy, but that's another video. Quantum computers will crack the world's online security and replace it with unbreakable quantum security. Any attempt to observe a message would destroy it. New patterns may also be uncovered in stock market data. Investment firms are betting on it. Voice recognition will be perfected, and we'll have more flowing, interesting conversations with our phones. New super light batteries will be designed. Planes will be optimized for hypersonic flight. The future impact of climate change will be modeled in detail. We might discover what really happens inside a black hole. And new models of particle physics will help unlock the secrets of nature. When AI meets advanced quantum computing, it will no longer need to learn one guess at a time. It will explore all possible choices at once. Today's specialist AI, which beats humans at specific tasks like chess and driving, will take a leap towards the holy grail of general AI, and perhaps superhuman intelligence. Quantum computers may be the tool to help create our final invention. So, where are we now? Well, Google has reportedly achieved quantum supremacy, cracking a task that would have taken 10,000 years on a classical computer. The task may be abstract, but it's a sign of things to come. AI will help form the algorithms required to take quantum computers and AI itself to the next level. Governments are pouring money into the quantum race. The US has invested $1 billion, believing it's the exact place where federal R&D dollars are best utilized. China has reportedly invested several billion. A follower in the digital revolution, it wants to lead the quantum revolution. Thousands of researchers are accessing quantum computers online. Like early classic computers, the technology is quietly gearing up for a revolution. A key challenge is to add qubits without creating interference. Oxford Quantum Circuits, which kindly supported this video, saw that a traditional layout wasn't scaling well, so it took the control and readout devices out of plane to reduce crosstalk. The team is taking an open, collaborative approach to spur innovation. Anyone can freely access and program quantum computers online. Professor Aspuro Guzik says, you have to hack quantum computers. Growing up in Mexico, he hacked phone systems to get free calls, and he sees the same adventurous spirit in the people connecting to quantum computers online. Maybe it's not about how many qubits we have, he says. Maybe it's about how many hackers we have. The qubits at the center of all this defy conventional thinking, and even their name. Bit is short for binary digit, but there's nothing binary about a qubit. Creative thinking will prise open the potential of quantum computers and change the world in ways we cannot imagine.
Coevolution and competition on Earth led to the only generally intelligent species known to date, humans. We hope that with a much larger and more diverse environment, truly complex and intelligent agents will one day emerge.